User-defined routes, UDR, allow administrators to customize how traffic is routed within a virtual network. By default, Azure installs a series of system routes that direct traffic among subnets, virtual networks, and the internet. However, certain scenarios require more granular control to ensure traffic follows specific paths, such as directing traffic through a network virtual appliance or optimizing data flow. UDR leverages custom route tables, which replace or supplement Azure's default routes. This feature is key for advanced networking scenarios like forced tunneling and multi-tier network segmentation. It ensures that organizations can tailor network flows according to complex security or compliance needs. Azure's default routing framework is designed to simplify connectivity across subnets and resources. System routes automatically forward traffic based on destination IP addresses, eliminating manual intervention. Nonetheless, user-defined routes offer customizing capabilities. Each route entry contains a destination prefix, a next hop type, and an address. The next hop type indicates how packets are forwarded, whether to a virtual machine network interface, a virtual appliance, or discard. This routing logic fits neatly into a route table associated with subnets. Understanding these fundamental concepts is essential for configuring scenarios that override the default routing to achieve specific networking goals. The first step in configuring UDR is to create a custom route table. In the Azure portal, navigate to the Network Resources section and select Route Tables. Click Create to supply a resource group, region, and name. Each route table can hold multiple route entries relevant to traffic destinations. Administrators typically place these in the same region as the target subnets for reduced latency. Once created, the table is initially empty. You can begin adding routes that define the destination prefix and the next hop. This process sets the groundwork for controlling paths that packets take within the environment. After creating a route table, administrators must associate it with one or more subnets. In the Route Tables panel, there is an option to bind specific subnets within a virtual network. Once linked, all outbound traffic from that subnet will adhere to the route configurations, overriding system routes if there is a matching prefix. This association is crucial because multiple subnets can share the same route table if they require identical routing rules. However, the table only impacts outbound flows from the attached subnet. Incoming traffic still relies on routing decisions made at the source or other network layers. When administrators add a custom route definition, they select a next hop type that indicates where traffic is forwarded. The options include Virtual Network Interface for direct traffic to a network interface, Virtual Appliance for forwarding traffic through services like firewalls, VPN Gateway for site-to-site tunnels, Internet to route traffic directly to external destinations, and None to discard matching flows. Each type corresponds to different operational needs. For instance, using a Virtual Appliance next hop helps centralized inspection of traffic, while routing to the Internet next hop enforces direct egress for specific prefixes. When using Azure VPN gateways or ExpressRoute connections, route propagation can dynamically add routes received from on-premises networks into subnet routing tables. By default, this property is enabled, ensuring automated updates to routing decisions. However, administrators sometimes disable route propagation to maintain strict control over user-defined routes. This might be relevant when forced tunneling or specific egress paths are requirements. Disabling propagation means on-premises routes will not automatically appear, so the organization must manually add any needed routes. Balancing dynamic routing flexibility with user-defined control is key for sophisticated hybrid network configurations. User-defined routes can override Azure system routes by specifying a matching or more specific destination prefix. For example, to force traffic from a subnet to pass through a network virtual appliance, administrators configure a 0.0.0.0/0 route that points to the appliance as the next hop. This override ensures that all outbound flows from that subnet follow the custom route, rather than taking the default path. Care must be taken to ensure that an appropriate firewall or forwarding mechanism is in place. Otherwise, connectivity might be disrupted. Proper design of route overrides is essential for advanced security or monitoring needs. User-defined routes support a variety of scenarios that demand precise traffic steering. One prominent example is forced tunneling, where all internet-bound traffic is redirected to on-premises resources for auditing or filtering before leaving to external networks. Another scenario involves using virtual appliances, such as next-generation firewalls, to inspect or shape traffic. Additionally, organizations that adopt network segmentation strategies can route specific flows through security layers in different subnets. These configurations assist in meeting regulatory obligations or corporate security standards. By defining multiple routes in a table, administrators orchestrate how each subnet's traffic is processed and ultimately delivered. After configuring a route table and associating it with a subnet, it is advisable to validate functionality. Administrators often deploy test virtual machines in affected subnets and use tools like Ping or Tracer to verify the route path. Proper logging in Azure Network Watcher can highlight whether packets are following the intended next hop. If unexpected behavior occurs, verifying that the destination prefix is correct and that the next hop is reachable helps pinpoint misconfigurations. Reviewing network security groups, NSGs, is also recommended, as they might block traffic despite correct routing settings. Thorough testing helps avoid disruptions. Aim to use the smallest set of custom routes necessary for clarity and maintainability. Overly complex route tables can become difficult to troubleshoot. Rely on Azure's default routing where possible, and only override routes for well-defined operational requirements. Keep route tables separate based on environment, production, staging, or development to avoid accidental cross-domain impacts. Ensure that critical subnets providing essential services are configured with failover or alternative routes. Finally, maintain documentation of each custom route's purpose, along with diagrams showcasing data flows. This approach simplifies collaboration among teams and helps maintain robust, secure, and transparent network architectures.